Okay, so we're going to do the second proof by induction here, which is proofs involving divisibility. So I don't need to go through how to do a proof by induction because we already know. So it's the same thing. Basic step is where we prove the statement true for n equal to 1. So the statement here is prove by induction that 3 is a factor of 4n minus 1 for all n is an element of natural numbers. So n equal to 1 is the smallest natural number, so it becomes 4 to the 1 minus 1, which is 4 minus 1, which is 3, and I don't know what you say, 3 is a factor of 3. Something like that. So it works for n equal to 1. So then the next step is the assumption. So the assumption is to assume the statement is true for n equal to k. So that becomes 4 to the k minus 1 is divisible by 3, or 3 is a factor of it. So 4 to the k minus 1 over 3 is equal to, you can use any letter, I'm just using A, where A is a whole number. Yeah, so where A is an inch, as in A is a whole number, because if 3 is a factor, then 3 will divide in and the answer will be even. And then if we rearrange this, as in, what did I do there? I multiplied by 3 and I multiplied by 3. So we get that. Okay. Then we have the inductive step. So that is to prove that the statement is true for n equal to k plus 1 based on the assumption that we made in the previous step. Yeah, so like we did with the series ones, we're going to make use of the assumption in this bit of the proof. So 4 to the k minus 1 becomes 4 to the k plus 1 minus 1. Yeah. We did a lot of this when we were doing indices. So adding the powers like this. So when you multiply two inequalities with the same base, you add the powers. So I'm going to undo that. So 4 to the k times 4 to the 1. Yeah? So this going this way is law 1 of indices, where if you multiply two indices with the same base number, you add the powers. I'm just using it the other way. Now, if I rearrange this, I get 4 to the k equals 3a plus 1. So if I plus 1 here and plus 1 here, and then I'm going to use that down here. So instead of 4 to the k, I'm going to put in 3a plus 1. 4 to the power of 1 is just 4, and then minus 1. And then I'm going to multiply this. So that is 12a plus 4, and then minus 1, which is 12a plus 3. Now, is that divisible by 3? Yes, it is. I can take 3 out. So that means if I could take 3 out, 3 must be a factor. Oh, crap. Ah. I'm just going to go back to my little thing. Yeah. So if I can take the 3 out, then it's divisible by 3, and then if it's divisible by 3, then I've proven it. It's true for n equal to 1. It's true. We're assuming it's true for n equal to k and proving it's true for k plus 1 based on this assumption. Then by induction, we've proven that it's true for all. Yeah? Okay, we will do another one. Okay, so same process, basic. Looking over here, so we are going to prove the statement true for n equal to 1. So that becomes 10 to the 1 minus 7 to the 1, which is 10 minus 7, which is 3. And 3 is divisible by 3. So it's true for the basic step, the n equal to 1. So then the assumption again is assume that the statement is true for n equal to k. So that gives me 10 to the k minus 7 to the k is divisible by 3, which means 10 to the k minus 7 to the k divided by 3 equals a, where a is a whole number. Okay, so then the inductive step. We're going to prove that the statement is true for n equal to k plus 1 based on the assumption. So it becomes 10 to the k plus 1 minus 7 to the k plus 1. And we need to prove, using the assumption, that this is divisible by 3. So I'm going to do the law 1 thing again. So 10 to the k times 10 to the 1 minus 7 to the k times 7 to the 1. I could probably do either. Anyway, I'm going to go back up here. Yeah. Sorry. Go back. Sorry. All of it, as in, yeah. And I'm going to rearrange this, so I get 10 to the k minus 7 to the k equals 3a. So if you multiply here by 3 to cancel, and multiply here by 3 then to balance out. And then if I rearrange here, so if I plus 7 to the k and plus 7 to the k, I get 10 to the k sorry, 10 to the k equals 3a plus 7 to the k. I'm going to sub that in. So this is 3a plus 7 to the k times 10 minus 7 times 7 to the k, if I just switch those around. This one I'm going to multiply out distributively, so I get 30a plus 10 times 7 to the k minus 7 times 7 to the k. Yeah, this is working. Sorry. So 30a is fine. Here I'm going to take the 7 to the k out as a common factor, which leaves me with 10 minus 7. So it's 30a plus 3 times 7 to the k. And just like I did the last time, I can take the 3 out as a common factor, which leaves me with 10a plus 7 to the k. So that implies that n equal to k plus 1 is divisible by 3. So if that is divisible by 3, then I can take my statement again. Yeah, so your finishing statement is always the same. Doesn't need to be quite so giant. Okay. Right, I think I may as well do the last one while we're here. So, same again. So prove by induction that this time I'm looking for is divisible by 2. Again, it is all natural numbers, so we are going to prove that the statement is true for n equal to 1. So that is 1 squared plus 3 times 1, which is 1 plus 3, which is 4, and 4 is divisible by 2. So that's that. The assumption is to assume the statement is true for n equal to k. So that becomes k squared plus 3k is divisible by 2, or that k squared plus 3k divided by 2 will give me a being a whole number. All right, next is the inductive step. So that is where we prove the statement to be true for n equal to k plus 1 based on the assumption. Okay, sorry, I don't have enough space for any of these. Okay, so just so I can see it there. So k plus 1 is going to be k plus 1 squared plus 3 times k plus 1. Yeah, that's the statement. N squared plus 3n. So, okay, right. If I expand, I've got k plus 1, and this is 3k plus 3, and that was not an equals, it was a plus. Yeah, so I did that. This one then becomes k squared plus k, so plus 2k plus 1 plus 3k plus 3. Adding the families, I get k squared plus 5k plus 4. Okay, same as I always did. At this point, I'm going to go back up to the assumption. I'm going to multiply by 2 to get rid of that. So I have k squared plus 3k equals 2a. And then I'm going to isolate my k squared. So minus 3k minus 3k. And I get k squared equals 2a minus 3k. Put that in down here. So 2a minus 3k in place of k squared plus 5k plus 4. So 2a, these two are from the same family. So that's plus 2k, and then that's plus 4. And that works because I was looking for divisible by 2, and I can take 2 out as a common factor. So that implies that n equal to k plus 1 is divisible by 2. Obviously, again, making use of the assumption, so I can make my final statement. Right, so that's it. That is divisibility. I quite like those ones, actually. So I've done 3 there. There's loads here. all divisibility, as you can see. So there's 15 there you can try, and I don't have them in yet, but in here I'll put in whatever has come up in the papers, and you can work away on them as well. All right, 2 down, 1 to go.